Hello viewers, my name is Mr. Adebanjo. I want to strongly welcome you to this video. And in this video, we are going to be discussing on Pythagoras Theorem and its application. We're going to be discussing Pythagoras Theorem and how to use Pythagoras Theorem. We're going to be discussing extensively on Pythagoras Theorem and how to apply it, where to apply it, and how we can make good use of the Pythagoras theorem. Now, this video is a part of a video we are going to make on trigonometric ratio. So, this video is going to be added to the playlist of trigonometric ratio because the reason why we are creating this Pythagoras, we are starting with Pythagoras theorem, or the reason why we are creating this Pythagoras theorem is because of trigonometric ratio. So we want students to understand Pythagoras theorem, and once you understand Pythagoras theorem, then you will know the reason why we need a trigonometric ratio. So this video is going to complement trigonometric ratio. We are going to upload the video very soon. So like I said, in this video, we are going to be discussing extensively on a Pythagoras theorem, how we can use it and where we can use it. So like I said, we are going to be discussing Pythagoras theorem in this video. So whether you understand Pythagoras theorem before or you don't understand it, this video is for you all. Now, before we get it started, if you are yet to subscribe to this channel, please click on the subscribe button right now so that you will be notified whenever we post information on this platform. And please share the videos, like it, and comment in the comment section of this video so as to help us improve on the new video we are going to post very soon. So Pythagoras theorem. Of course, Pythagoras was a mathematician like myself. He was the one who propounded Pythagoras theorem and he named it after himself. So what is Pythagoras theorem and how can we use it? That's the question we need to ask ourselves. What is Pythagoras theorem saying and how can we apply it and how can we use it? Now we'll start with the knowledge of triangle, because we know that a triangle is one of the plane shapes that we have. It is a two-dimensional shape. So we know that it has three sides and three angles. So we know that we have different types of triangles. We have isosceles triangle, we have equilateral triangles, we have a right angle triangle, and other type of triangles that we have. So we are not to mention know the type of triangle that we have. I'm just saying that so that to know the basis of this video while we are studying Pythagoras theorem. So knowing that we have different types of triangles, it means that Pythagoras theorem is not applicable to all these type of triangles, but only one out of all. Pythagoras theorem is only applicable to right angle triangle. Pythagoras theorem is only applicable to right angle triangle. Since we know that we have other type of we have different types of triangle, but Pythagoras theorem is only applicable to one out of all, and that is a right angle triangle. So that means that you cannot apply Pythagoras theorem to solve isosceles triangle. You cannot apply it to solve equilateral triangle and other type of triangle that we have, but it is only related or applicable to right angle triangle. Having known this, how do we identify or how do we know that a triangle is a right angle triangle? If I'm given a triangle, how do I know that this triangle is a right angle triangle? Knowing that we have different types of triangles. So how do I identify a triangle that is a right angle triangle? Now, since you know that in a triangle we have three angles in a triangle, so if you have a triangle and you can see that one of the angles of that triangle is 90 degrees, that means that triangle is a right angle triangle. What do I mean? If you can see the triangle we are having on the screen right now, we can see that it has an angle here, another angle is here, then the third angle is here. But this third angle, you can see that it's a right angle. It's a right angle. So this angle here is a right angle, which is equal to 90 degrees. So that makes this triangle a right angle triangle. When you have a triangle and one of the angles of that triangle is a right angle, that is equal to 90 degrees, that made that triangle is a right angle triangle. So this triangle is a right angle triangle. So if you want to know better on all the triangles, you can check one of my videos I've made on a plane geometry on triangles and all the rules that we have on the triangles. So you may check the video, you may check the playlist of plane geometry. You will see the video there. So this triangle is a right angle triangle because of this right angle here. So then it means that the Pythagoras theorem is only applicable to a right angle triangle. Now, then if you know that the Pythagoras theorem is applicable to right angle triangle, then since we have sides in a right angle triangle and we also have angles in a right angle triangle, where can we apply Pythagoras theorem? Can we apply it to resolve the angles, or can we apply it to resolve the side only? The answer is we can only use Pythagoras theorem to resolve the sides of right angle triangle. Pythagoras theorem does not have any relationship with the angles of a right angle triangle. But Pythagoras theorem only deals with the sides, the three sides of a right angle triangle. I hope you are following me. So Pythagoras theorem does not it cannot be applied to solving the angles inside a right angle triangle. That is where trigonometric ratio comes in. But we are not here to discuss trigonometric ratio right now. We are discussing Pythagoras theorem that it only deals with the three sides of a right angle triangle. Having known that, then what is Pythagoras theorem saying? Before we talk about what Pythagoras theorem is saying, out of these three sides of this right angle triangle, we have this side, we have this side, we have this side. Out of these three sides, one of the side is called an hypotenuse, or sorry, hypotenuse. So out of these three sides, one of the side is called an hypotenuse side of this triangle. The question is, how can we identify this hypotenuse side? Some of the teacher will tell you that it is the longest side of the triangle, but I can convince you on that notion. If I remove this triangle, this rectangle and I put it here, and I put this rectangle here, or if I remove it here and I put it here, so where is still the longest side? This is still the longest side, and that is no longer going to be the hypotenuse side. So the hypotenuse side is not necessarily the longest side of the triangle, but it is the side that is facing this right angle. Any side facing the right angle is the hypotenuse side. I hope you can hear what I'm saying. The side that is this is right angle here. So whenever they put the right angle in the triangle, whenever they put this right angle in this right angle triangle, then the side that is facing it is the hypotenuse side. So the right angle is here. That make this side the hypotenuse side. If I put the right angle here now, that make this side the hypotenuse side. If I put the right angle here, that make this side the hypotenuse side. So any side that is facing the right angle is the hypotenuse side of the right angle triangle. I hope I'm clear. Now, if you understand that, now let's now talk about the Pythagoras theorem. The Pythagoras theorem is saying that the square of the hypotenuse side. Now that we know where the hypotenuse side is, which is this side because it is facing this right angle. So it's saying that the square of the hypotenuse side, that is square this side now. We have already labeled this side A. We call it A. So we say you should square it. The square of the hypotenuse side is equal to the sum of the square of the two remaining sides. It's very simple. That is, square the hypotenuse side, then it is equal to the sum of the two remaining sides when you square them. So you square this side and square this side and add it together. It's going to be equal to this side, square of this side. I want you to understand this very well. That is, the square of the hypotenuse side is equal to the sum, that is addition of the squares of the remaining two sides. That is, when you the square of this side is equals to sum of the square of these two remaining sides. So square this, add it together. It's going to give us it's going to be equals to the square of this hypotenuse side. So that is a squared, this hypotenuse side, is equals to b square, or anyone, whether c square or plus b square, or b square plus c square, anyone you want to, anyhow you want to write, it's still the same thing. That is, the square of the hypotenuse side, which is a squared, is equals to b square, that is the square of this side, plus the square of this side, which is c square. So that is what the Pythagoras theorem is saying. That is, the square of the hypotenuse side, locate the hypotenuse side, then square it, is equals to the sum of the square of the remaining two sides of that right angle triangle. Do we understand that fully? Do we understand that? So if you understand this, let's see this now. Look at this triangle now. You know that this triangle is also a right angle triangle. Why? Because there is a right angle here. And if this is a right angle, can you tell me the hypotenuse side of this right angle triangle? I want you to tell me the hypotenuse side of this right angle triangle. Of course, it is still this side, because it is facing this right angle. So that means side AC is the hypotenuse side. Now, if you look at the previous triangle that we talked about, we only label this side A, B, and C. So it means that we can also name the edge of the triangle as well. Like we have here, this edge is called A, this edge is called C, and this edge is called B. So that means this side can be named side AC, side AB, and side BC. So as I was saying before, this is a right angle triangle, and this side is the hypotenuse side because it's facing the right angle. Then how can we apply the Pythagoras theorem here? Now Pythagoras theorem is going to be, if you want to say the Pythagoras theorem for this right angle triangle now, that means you'll be having the square of this side, which is the hypotenuse side, that is AC squared, the side AC squared, this side. So AC squared is equals to AB squared, which is this side, plus BC squared, which is this side. So the Pythagoras theorem for this triangle is going to be side AC squared is equals to side AB squared plus side BC squared. That's it, the square of the hypotenuse side is equal to the sum of the square of the remaining two sides of that right angle triangle. I hope you understand that. Now, before we can apply Pythagoras theorem to solving the side of a right angle triangle, a condition must be satisfied. And what is the condition? You must be given at least two sides of that right angle triangle before you can use Pythagoras theorem to find the third side. I hope I'm clear with this statement. I said before you can apply Pythagoras theorem, you must be given at least two sides of the right angle triangle to find the remaining one side. So that means if I'm giving only one side of a right angle triangle, I cannot apply Pythagoras theorem. If I'm giving two sides of a right angle triangle, then I can apply Pythagoras theorem to find the third side. So if you are given only one side, you cannot apply Pythagoras theorem, and that is where trigonometric ratio comes in. But we're not going to discuss that in this video. So I'm just preparing your mind towards what we are going to be discussing in trigonometric ratio. So this Pythagoras theorem will only work when you have two sides given already, then you're looking for the remaining third sides. I hope I'm clear with that as well. Now, if you understand this now let's start solving question with this Pythagoras theorem. Now, the first question we want to solve in using Pythagoras theorem is the question we are having on the screen right now. You can see that this is a right angle triangle. Why? This is a right angle here, so that makes it a right angle triangle. Then, if you look at the triangle, we are given two sides. We are given that this side is 5, 5, and this side is 3. So we are looking for this side, and it is named x. The question is, can we apply Pythagoras theorem here to find the third side? Yes. Why? Two sides are given, and this triangle is a right angle triangle. So we can apply Pythagoras theorem to find the third side. Don't forget, we are not asked to find the angle inside the triangle, but we are asked to find side. And the Pythagoras theorem is only dealing with side of the right angle triangle. So since we can apply Pythagoras theorem now, because all the condition for using Pythagoras theorem is satisfied in this question, so then what will be well, if you formulate the Pythagoras theorem, what will it become? All you need to do is to first identify the hypotenuse side. Where is the hypotenuse side? This is the side, and because it's facing the right angle, so that means this side is the hypotenuse side. That means the Pythagoras theorem say that you should square the hypotenuse side, which is 5 square, equals to the square of the remaining two sides added together. The sum of the square of the remaining two sides added together equals to the square of the hypotenuse side. So that means you'll be having 5 square equals to this side, square of this side is 3 square plus the square of this side is s squared. So I hope you understand this. Then you can move further to say 5 square is 25 equals to 3 square is 9 plus s square. From there, you know what to do. You can collect like terms from here by making s squared the sort of the formula. Then 9 will go to this side. That means you'll be having s squared, which is this, equals to, when 9 comes here, you have 25 minus 9. And 25 minus 9 will be 16. Then our aim is to find x, not s squared. So how do you find x? You can find the square root of both sides. So square root of x squared will give us x. Then square root of 16 will give us 4. So that means this side of this triangle is 4. So that is possible because we are able to apply the Pythagoras theorem to resolve the side of this triangle. So let's see another question that could challenge us a little bit. Now you can see this triangle now. The triangle is not like the one that we just solved now, but you can see that it is still a right angle triangle, although it is not placed very well, but yet it is a right angle triangle. Why? Because this angle here is a right angle, and that makes this triangle a right angle triangle. Are we clear about that? Then if it's a right angle triangle, then where is the hypotenuse side? Where is the hypotenuse side? The hypotenuse side is this side. Why? Because it is facing this right angle. Then how many sides are given in this triangle? Two sides are given. This side is given 20 centimeter. Excuse me. This side is also given 15 centimeter. Then we are looking for this side, which is the hypotenuse side, and that is labeled y. Then if you formulate the Pythagoras theorem for us using this triangle, what will it be? Then that will be square of the hypotenuse side. That will give us y squared equals to the sum of the square of the remaining two sides, 20 squared plus 15 squared. Do we understand that? Then you can simplify further. 20 squared will give us 400. 15 squared will give us 225. Then 400 plus 225 will give us 625. Then from there, we can our aim to find y, not y squared, and that is by taking the square root of both sides. Square root of y squared will give us y, and the square root of 625 will give us 25. So we have been able to find this third side of this right angle triangle using Pythagoras theorem. I hope you understand this. Alright, let's move further. Now we are still having another question like this, still on a Pythagoras theorem. And you can see that this triangle also is a little bit bent, but we are not after that. Our aim is to we need to ask ourselves, is it a right angle triangle? Yes, it is a right angle triangle because there's a right angle in there, and how many sides is given? Two sides are given. This side is given 18 centimeter, and this side is given 15 centimeter. So we are looking for these two in the third side, which is labeled x. So it means that we can apply Pythagoras theorem to find the third side. And if you formulate the Pythagoras theorem, what will it become? where is the hypotenuse side? The hypotenuse side is this side because it is facing the right angle. Then the square of it, which is 50 squared, equals to the sum of the square of the remaining two sides. Square of this plus the square of this. So we have s squared plus 18 squared. 50 squared will give us 2500 equals to s squared plus 18 squared will give us 324. From there we can take the like times. 324 will come to this side, so we have s squared left here. So we have s squared is equals to 2500 minus 324. If you subtract that, you have 2176 as our s squared. Our aim is to find x, and that is only possible if you take the square root of both sides. So square root of s squared will give us x, and square root of 2176 will give us 46.6 approximately to one decimal place. So still we are still using the Pythagoras theorem to resolve the side of a right angle triangle. Alright, let's see another question that could challenge us. Now if you look at this diagram you have here, you can see that we are not having a single triangle now. We are having more than one triangle in this diagram. So it's quite different from the one that we have been solving. We have been solving single triangle before. Now we are having two triangles to be resolved. But I want to tell you, my listener, I want to tell the listener or the viewer that anytime we are having more than two on one triangle to be resolved using Pythagoras theorem, all you need to do is to first of all find out all the right angle triangle that we have in that diagram, and that will help you to be able to know what to do. So ask yourself, how many right angle triangle can I see in this diagram? If you ask yourself that question, then try to figure it out. But as far as I'm concerned here, I can see that we have two right angle triangle. This triangle here, the one I'm highlighting on, is a right angle triangle because of this right angle here. Then this second triangle, this one, also is another right angle triangle because of this right angle here. So it means that we have two right angle triangles to be resolved. Now, if that is the case, where do we start solving from? We need to ask ourselves that question. Where can we start solving the question? Or which right angle triangle do we start with? If you look at this first right angle triangle that we have here, we can see that we ask yourself how many sides is given to us. How many sides do we have presently in that triangle? This one. How many sides are we given? We are only giving this side to be 2.8. This side we don't know it, we call it y, and this third side we don't know it also, it is called x. So, and don't forget, you can only apply Pythagoras theorem when you have two sides given. When you have two sides given, that's when you can apply Pythagoras theorem. But in this case we are only giving one side. That means you cannot apply Pythagoras theorem yet. Let's look at the second triangle. Look at this triangle now, this right angle triangle here. How many sides is given in that one? We can see that two sides is given, or two sides are given. This side is given as 13, and the other side is given at 15. So the third side is x. So that means we can start with this triangle, this right angle triangle, this one, since two sides are given. So we can now use that to find this side. Then when we now do this side for this triangle, then we can now find the third side for that the second triangle as well. Do we understand that? So if that is well taken care of, then let's find this side, this third side for this triangle, and all you need to do is to ask yourself, where is the hypotenuse side for this right angle triangle? And that is the side facing this right angle, and that make this side the hypotenuse side of this right angle. So if that is the case, that should be 15 squared, which is the hypotenuse squared, equals to the sum of the square of the remaining two sides. That is the square of this plus the square of this. So we have s squared plus 13 squared. So 15 squared will give us 225 equals to s squared plus 13 squared is 169. Collect like times, you have s squared equals to 225 minus 169. And that should give us 56. Then if you take the square root of both sides, x will be equals to square root of 56, and that should give us 7.4. It means that this side which is labeled x, is 7.4. So this side is 7.4. It means that if this side is 7.4, that means we now have two sides in this third triangle, in this second triangle. Now we now have two sides. Since we already found this side to be 7.4, then that means you can now find this third side of that triangle, which is labeled y, because we now have two sides in this triangle now. Since we know this side now to be 7.4, then having known that, it means that we can also apply Pythagoras theorem to this triangle as well, since two sides are known now. Since we know this side and we know this side, so we can now use that to find this side y. And all you need to do is to formulate Pythagoras theorem with this triangle as well, and then that will be the square of the hypotenuse side. Where is the hypotenuse side for this triangle, this right angle triangle? That make this side the hypotenuse side, because this is the side that is facing this right angle here. So that means this side is the hypotenuse side for this right angle triangle. Do we understand that? So that shows that we have this hypotenuse side, the square of it, which is s squared, equals to this side is the square of this side, which is 2.8 squared, plus the square of this side, which is y squared. Are we there? But we already know our x to be 7.4, so that means you have 7.4 squared equals to 2.8 squared plus y squared. 7.4 squared will give us 54.76. Then from there is equals to 2.8 squared will give us 7.84 plus y squared. Then if you collect like times, you have y squared will be equals to 54.76 minus 7.84, because if you squared it, that gives us 7.84. Subtract it, that should give us 46.92. Then if you find the square root of both sides to find your y will be equals to 6.8. So that means this side is 6.8. So you can see how we resolve the diagram here, knowing that we have two right angle triangle, starting from this one and ending at the second one here. Now let's look at another triangle that we have here that could challenge us a little bit, still on a Pythagoras theorem. Now look at this triangle now. It's quite different from the one that we just solved now, in the sense that of course we can resolve this using Pythagoras theorem as well, but all you need to ask yourself, where are the right angle triangle that we have in these triangles? Where are the right angle triangles? Because I must tell you, we have more than two triangles in this diagram. So there's triangle PQR, and there's triangle PSR, and there's triangle PQS. PQS, this triangle here. So we have three triangles here in this diagram. But out of the three triangles that we have, which one is a right angle triangle? So because if you're able to find that out, then you know which one you are going to apply trigonometric ratio on. Because we know that, sorry, Pythagoras theorem on. I don't know why I keep mentioning trigonometric ratio. So because we know that Pythagoras theorem is only applicable to right angle triangle. So let's identify the right angle triangle that we have here. We have triangle PSR. This PSR is a right angle triangle. Then the triangle PQR, that big triangle, is also a right angle triangle. So PQR is a right angle triangle. Also PSR is also a right angle triangle. It means that this triangle PQS, it is not a right angle triangle. This triangle here, it is not a right angle triangle. So that means you cannot apply Pythagoras theorem on it. So we are having two right angle triangles here that we have mentioned. But what are we looking for in these triangles? We can see that we are looking for this side that is labeled X. From here to here, we are looking for this side. It is labeled X. And we are also looking for this side, which is labeled Y as well. So we are looking for QS, which is labeled X. We are looking for side PR, which is labeled Y. So the question is, how do we find those two sides? Now, if you look at it, like we have identified the right angle triangles that we have there, we can see that if you look at this triangle inside this right angle triangle PSR, we can see that two sides are given already in that triangle. PS is given as 15 centimeter and SR is given as 9 centimeter. So we can find the third side of that right angle triangle, which is labeled Y. Do we understand that? So PS is given, which is the 15 centimeter side. SR is given as 9 centimeter. So we can find our PR, which is labeled Y. And we can apply Pythagoras theorem here because it's a right angle triangle. And two sides are given already. Looking for the third side. The question is, where is the hypotenuse side for that right angle triangle PSR? I'll give you 1 second or 2 seconds. Let me give you 2 seconds to figure it out. Where is the hypotenuse side for this triangle PSR? So it is side PS. Side PS is the hypotenuse side because it is facing this right angle here. And so if you formulate Pythagoras theorem for us from triangle PSR, what's Pythagoras theorem? What will it say? That means you have PS, which is the hypotenuse side squared, which is 15 squared, equals to the sum of the square of the remaining two sides. That will be y squared plus 9 squared. From here to here is 9 square 9. So 9 squared plus y squared equals to 15 squared. And that is the Pythagoras. So that's the Pythagoras theorem for us. 15 squared is 225 equals to y squared plus 9 squared is 1. If you take the like times, you have y squared to be 225 minus 81, and that should give us 144. To find y, it takes the square root of both sides. Y will be equals to 12. So that means from PR, this side PR is 12 centimeter. Do we understand that? Now to find this side from here to here, which is x, that means we have to use the big triangle, which is also a right angle triangle. Why do we say that this triangle PQR is a right angle triangle also? If assuming that this line is not there now, assuming that this line PS is not there, you can see that you'll be left with this big right angle triangle, and that will make it that shows that it's also a right angle triangle. I hope you can see what I'm saying. Assuming that this line is not there, assuming that we can erase this line PS, so that means you'll be having PQR left as a right angle triangle. So it means that the triangle PQR is also a right angle triangle. Then from there, from that triangle PQR, how many sides do we have now? We have side PQ, 25 centimeter, and we also have this side PR, which is what we have gotten now, which is 12 centimeter. So then this side, part of it is given, which is 9 centimeter. So we are looking from here to here. So we can still apply Pythagoras theorem here. How? Where is the hypotenuse side for triangle PQR? It is this side PQ, because it is facing this right angle. So that means the square of it, which is 25 squared, equals to the square of this side, which is 12 squared, then plus the square of this side. And this side is addition of 9 centimeter plus x. Because from here to here, QR is same thing as RS, which is 9 centimeter, plus SQ, which is x. So the whole side here is 9 plus x. So that will give us 9 plus x squared. So the square of this hypotenuse side, which is 25 squared, equals to the square of this side, which is 12 squared, plus the square of this side, which is 9 plus x, all squared. I hope you understand that. Then 25 squared gives us 625 equals to 12 squared gives us 144 plus 9 plus x squared. We can collect like times from there. That will give us, if you take 144 to this side, you have a 9 plus x squared left, which is this, equals to 625 minus 144. 625 minus 144 gives us 481, equals to 9 plus x squared. How can we get rid of this squared? How can we get rid of it? Because we are looking for our x. So we can take the square root of both sides, take the square root of this, that will take care of this square. So take the square root of this as well. So if we take the square root of this, that means you'll be left with 9 plus x. equals to the square root of 481 is 21.9 approximately. Then from there, what I mean to find s, we can take 9 to this side to collect like times. So s will be equal to 21.9 minus 9, and that should give us s to be equal to 12.9. I hope you understand there how we have been able to use Pythagoras theorem to resolve the missing side of these triangles. So if you understand this, let's see another question that can challenge it as well. So look at this question as well. Look at this triangle as well. And I want you to pause this video and ask yourself how many rectangle triangle do we have in this diagram, and if you know the number of rectangle triangle that we have there, where do we start resolving the triangle from? I want you to pause the video and ask yourself that question. So I want to believe that you have figure out how many rectangle triangle that we have there and where to start from. So from here, I can tell you that we have 2 rectangle triangle here as well, which is this triangle, the small triangle inside this one, and the big one, the outer one, also is a rectangle triangle. So this triangle here, this one is not a rectangle triangle. So we have 3 triangles here, but 2 are rectangle triangle. So this one I'm highlighting on right now, it is not a rectangle triangle. So we have this small one inside to be rectangle triangle, and we have this big one. Why? If I erase this line, assuming that this line is not there, you still call that this big triangle is a rectangle triangle. Then this line plus this one also is a rectangle triangle. So we have 2 rectangle triangle in this diagram. The question is, where do we start from? Do we start from the big triangle, or we start from the inner one? Knowing that I want to apply Pythagoras theorem here. Now, where do we start from? Because we are looking for this side, which is x. We are also looking from here to here, which is y. So from here to here is labeled y. From here to here is labeled x. Where do we start from? Do we start from the big triangle, or we start from the inner one? So the answer is we start from the inner one. Why? Because if you look at the inner triangle, which is a rectangle triangle, how many sides are given? This side is given, and from here to here is also given. So the third side is what we are looking for. So that we can apply Pythagoras theorem to the inner triangle, which is this one. Look at the bigger triangle, the big one, which is also a rectangle triangle. We cannot apply Pythagoras theorem yet. Why? This side is given, so this side is not given. Everything here is not given. You only know from here to here to be 12. We don't know from here to here, and we also don't know this side as well. So it means that we cannot apply Pythagoras theorem to this big triangle yet, but we can apply it to the inner one. So from the inner one, where is the hypotenuse side of this rectangle triangle here? So this is the hypotenuse side. This side 13, this side that is labeled 13 is the hypotenuse side, because it is facing this right angle. So that means the square of the hypotenuse side, which is 13 square, equals to sum of the square of the remaining 2 sides, from here to here plus from here to here. That will give us 12 square plus s squared. So 13 squared is 169, equals to 12 squared 144 plus s squared. Collect the like time, take this to this side, you have s squared equals to 169 minus 144, that gives us 25. Take the square root of both sides, x will be equal to 5. So that means from here to here, which is x, is equal to 5. Do we understand that? Now that we understand that, that means to now find the value of our y here, we can now use the big triangle, which is also a rectangle triangle. And in that rectangle triangle now, we have this side given, and we also know this side, which is labeled x, to be 5. So now we can now apply that to solve the whole from here to here as well. We can apply Pythagoras theorem to solve for our y using the whole side here. And how do we do that? Knowing fully whether this is also a rectangle triangle, then where is the hypotenuse side? That means this side is the hypotenuse side because it is facing this right angle. So the square of the hypotenuse side, which is 18 squared, equals to the square of this side, which is s squared, plus the square of this side, which is 12 plus y all squared. I hope you understand that. So we have 18 squared equals to s squared plus open bracket 12 plus y, which is addition of this side, from here to here plus from here to here, which is this side, square of it. Then 18 squared is 324. Our x squared here is 25. Or if we put your s to be 5, then 5 squared will give us 25 plus 12 plus y all squared. From there, you can collect like times. This 25 comes here. You have a 12 plus y all squared left equals to 324 minus 25. That will give us 299. Then how do we get rid of this square? You can take the square root of both sides. So that should give us 12 plus y equals to square root of 299. Square root of 299 is 17.3. Then from there, you can take the like times. 12 will come to this side. You have y to be equals to 17.3 minus 12. Y is going to be 5.3. So that means from here to here is going to be 5.3. So you can see how we'll resolve this triangle using Pythagoras theorem. If you understand this, now let's take it to another level. Now look at this triangle as well. Look at this triangle that we are seeing on the screen right now. We can see that we have more than one triangle. This is a triangle, another triangle, and the big triangle is also another triangle. But we need to ask ourselves, where are the right angle triangle in these triangles? Now you can see that there's a right angle here that make this triangle a right angle triangle. Also, this triangle also is also a right angle triangle, because some angle on a straight line is 180 degrees, and if this angle here is 90 degrees, that means angle here is also what, 90 degrees as well, because sum of angle on a straight line is 180 degrees. So if from here to here is 90, that means from here to here is also 90 degrees. So that means this triangle here is a right angle triangle, and this triangle here is also a what, right angle triangle. But the big triangle is not a right angle triangle, because there's no a right angle in the triangle. So no right angle here, no right angle here, no right angle here. So that means the big triangle is not a right angle triangle. Rather, this triangle is a right angle. So it's a right angle triangle, and this triangle is also a right angle triangle. Do we understand? What are we looking for? We are looking for this side, which is labeled y. We're also looking for this side, which is labeled x. From here to here, we are looking for, it is labeled x. Then where do we start from? Do we start from this right angle triangle? No, we cannot start from here, because if you look at that right angle triangle, no side is given at all. This is y. We don't know this side. We also don't know this side. But if you look at this triangle, read this right angle triangle, how many sides are given? This side is given 15 centimeter, and this side is also giving 9. Sorry, this side is giving 15, and this side is also giving 9 as well. So that we can start from this right angle triangle. Do we understand that? And you can see that we have stripes, two stripe on this side and two stripe also on this side. It means something. It means that this side is equal to this side. So this side is equal to this side. So if you're able to get this side, that means you also know this side as well. So from there, I said we are going to start with this right angle triangle, because two sides are given already. This side is given and this side is given. So we can find this third side of that right angle triangle. The question is, where is the hypotenuse side? The hypotenuse side is this side, because it is facing this right angle here. So that means the square of this side, which is 15 squared, equals to k squared. Where do we see k? That means we label this side k to make it easier for us. So we label this third side you are looking for, we label it k. So we have k squared plus this side, which is 9 squared. So we are still applying Pythagoras theorem. The square of the hypotenuse side, which is the square of this, is equal to sum of the square of the remaining two sides, which is this side, which we have already called k, the square of it plus the square of this side, which is 9 squared. So 15 squared is 225 equals to k squared plus 9 squared is 81. Collect the like times. We have take 81 to this side. You have k squared equals to 225 minus 81. 225 minus 81 give us 144. So we can find our k there by finding the square root of both sides. So k will be equal to 12. That means this side is 12. So if this side is 12, that means this side is also what? 12 as well, because they are equal. or these two stripe is here, there's also two stripe here. So that means this side is equal to this side. So this side is 12. I mean, this side is also 12. So that means you can find the whole side here as well, which is labeled x. So if from here to here is 12 and from here to here is 9, so what will be the value of our x in that case? So x should be from here to here plus from here to here. So s is going to be k, which is from here to here, plus from here to here, which is 9. So from there, from here to here is what? 12, as you have gotten here, plus 9. That should give us 21. So x is 21. From here to here is 21. Now, if you are not that, let's find the value of our y, which is this side. And we can only find this side using this right angle triangle. And in this right angle triangle, we have how many sides given now? We have this side given, which is 12 centimeter. We also have this side given also, which is 12 centimeter, because they are equal. So if these two sides are equal now, we know them, so we can find the third side using Pythagoras theorem. Where is the hypotenuse side? This is the hypotenuse side because it's facing this right angle. So that means the square of the hypotenuse side, that will give us a y square equals to the square of this side, which is k square, plus the square of this side, which is k square as well. So, and this side is 12. So, and the square of 12 will give us 144. And this side is also 12. The square of this side also is 144. Add it together, that gives us 288. Then to find our y, take the square root of both sides, that should give us a 16.9. So that means this side is a 16.9. I want to believe you have been learning one or two things in this video so far, using the Pythagoras theorem. Before we continue to the next question, if you are here to subscribe to this channel, please click on the subscribe button on this channel right now as you are watching. Please share the video, like the video, and leave a comment in the comment section, and then give the thumb up to this video so that you will help us improve the video. Let's continue on this journey of Pythagoras theorem. Now let's look at this question as well. We are given this triangle to resolve. We are looking to find the length of DC, which is from here to here. We got to find the length of DC, which is from here to from D to C, which is from here to here. Now we have to looking for this side. Now the question is, where are the right angle triangle in this diagram, in these triangles? How many right angle triangle do we have there? You can pause the video and answer the question. How many right angle triangle do we have in this video? So I will tell you that we have three. We have three in this video. In this diagram, we have three right angle triangle. That is, all the triangles are right angle triangles. This triangle DBC, this one is a right angle triangle because this is a right angle here. This triangle ABD also, this triangle is also a right angle triangle because if this is 90, then this is also 90. Angle on a straight line is 180 degrees. Then also you can also see another right angle here. Another right angle is also here, which belongs to triangle ABC. Triangle ABC. The big triangle is also a right angle triangle. So it means that all the triangles in this shape, in this diagram, they are all right angle triangle. So, and don't forget, we are looking for DC, which is from here to here. Then ask yourself, where can we start from? Can we use this triangle to find DC, since DC belongs to this right angle triangle DBC? Can we just find it straight away? Ask yourself that question. The answer is no, we cannot. Because if you look at this triangle DBC, where this DC we are looking for belongs to, we are only giving one side for that triangle. Only BC is given. So this side we don't know, this side also we don't know. So that we cannot use this, you cannot solve this, you cannot find DC now using this triangle because only one side is given. Let's look at this triangle ABD. ABD. How many sides is given in that one? Two sides are given. This side is given and this side is given. So we can find this side, which is BD, and this BD is being shared by this triangle and this triangle. So if you can find this BD, then if you know BD and we know this side as well, we can now find our DC. Do we understand that now? So from this triangle now we can find our BD. knowing that this side is given and this side is also given, and this triangle is also a right angle triangle. So that we can apply Pythagoras theorem. So from triangle ABD, which is this, formulate Pythagoras theorem for us. What will it become? Or where is the hypotenuse side for this triangle ABD? This side is the hypotenuse side. Side AB is the hypotenuse side. Why? Because it is facing this right angle here. There's a right angle here that we did not put. So this is a right angle here as well, because angle on a straight line is 180. This angle is 90. That means this also 90 degrees. So that makes this side AB hypotenuse side because it's facing this right angle. So the square of the AB side AB equals to the square of AD plus the square of BD as well. So that means you have a 15 square equals to 8 square plus BD square, which is this side. So that gives us 225 equals to 64 plus BD square. Then from there, you can collect like times, take 64 to this side. So you are left with a BD square equals to 225 minus 64. That gives us 161. Then to find our side BD, take the square root of both sides. BD will be equal to square root of 161. That gives us 12.7 centimeter approximately. So that means this side, it is 12.7 approximately. So if you now look at this triangle BDC, we are looking for DC. Now we now have two sides given. We know this side BD and we know this side BC, so we can find our DC now using Pythagoras theorem. Also, now all we need to do is to, where is the hypotenuse side for this right angle triangle BDC? This side is the hypotenuse side because it's facing this right angle here. So that means we have a BC square equals to BD square plus DC square. Don't forget we are looking for this DC. So BC is 20. That means you have 20 square equals to BD square is 161. BD square is 161. You have it here plus DC square, which is what you are looking for. 20 square is 400 equals to 161 plus DC square. Collect like times. Make DC square the square of the formula. That means you take this one to this side. So we have DC square equals to 400 minus 161. That gives us 139. Our aim is to find DC. Take the square root of both sides. So we have DC equals to square root of 239, which is going to give us 15.5 centimeter approximately. So that means from here to here is a 15.5 centimeter. I hope you understand that question very well. Good. So if you understand that question now, let's resolve this diagram as well. It's very similar to this the one we just solved now, but something is just a little this one is just a little bit harder than the one we just solved now. Now we have to look for the value of this side, which is called x. So we're looking for side SR and this is tag x. So the question is, how many right angle triangle do we have in this diagram? How many right angle triangle do we have in this diagram? We have 3. So this is right angle triangle, this is a right angle triangle, and the big one is also a right angle triangle because there is a right angle here. So if that is the case, we are looking for from here to here, which is our x, which belongs to triangle SQR. So from here to here belongs to triangle SQR. But if you look at that triangle SQR, only one side is given, QS is given. We don't know this side and we don't know this side. So that we cannot find this side using this triangle. Let's look at this triangle PQS. If you look at that triangle as well, how many sides are given? 2 sides are given. So this side is given, this side is given. So we can find this side as well. But if you find this side, does it relate to this triangle? No, it does not have any relation to do with this triangle to find this side. So even if you know this triangle, this side of this triangle, it will not still help us to find this side. So what else can we do? Now if you know this side, then that can help us using the big triangle, because this the triangle PQR as well, which is the big triangle, is also a right angle triangle as well because there's a right angle here. So that we can also apply Pythagoras theorem to that one as well, knowing that it's a right angle triangle. So with that means if you can find this side, then we know this side from here to here is 12, and we know from here to here is also x. So we can use that to find our x. How? So we have to start with the one that is given to the one that we have two sides given, which is this triangle PQS. So and how do we do that? But before we before we do this, we can start from triangle SQR, which is the one that have X you are looking for. From triangle SQR, we can apply Pythagoras theorem here. Where is the hypotenuse side? This is the hypotenuse side. So that we have QR squared, which is the hypotenuse side. QR squared equals to this square, which is 16 square plus X square. 16 square is 256 plus X equals to SQR square. So there's nothing we can do further in this one, so we can leave it there. We are coming back to it. Let's go back to the second triangle here, which is triangle PQS. In this triangle, we have two sides given. This side is given, this side is given. So we can apply Pythagoras theorem here as well. So that where is the hypotenuse side? That is PQ. PQ is the hypotenuse side. So we have PQ square equals to the square of this side plus the square of this side, which is 16 square plus 12 square. So PQ square is going to give us 16 square is 256 plus 12 square is 144. That gives us 400. So PQ square is 400. Now let's leave that as well there. Now if you now go to the main triangle, which is the big triangle here, which is this one, it's also a right angle triangle. But where is the hypotenuse side? Where is the hypotenuse side of this triangle PQR? Knowing that it's a right angle triangle because of this right angle here. So that means this side is the hypotenuse side. Side PR is the hypotenuse side because it is facing this right angle here. This right angle here. So that means this side is the hypotenuse side. So that means we have PR square equals to the square of this side plus the square of this side. So we have PQ square plus QR squared. Do we understand that? So using this triangle, this big triangle, we have the hypotenuse side, which is this, is equals to this plus this. So PR square equals to PQ square plus QR square. What is our PR? Side PR. Side PR is from here to here, which is 12, plus from here to here, which is X. So we have 12 plus X squared. Do we understand that? So then equals to PQ square. What is PQ square? We know PQ square to be give us a 400 here. So PQ square is equal to 400. You have 400 plus QR square. QR square. We have already gotten this QR from this triangle. QR square is equals to 256 plus S square. So that return that one here. You have 256 plus S squared here. Do we understand that? So if that is the case, you are only replacing our QR square with this one because QR square is equals to 256 plus S square. So put that here, you have this. Then from there, what do? We can expand this bracket. We can expand this bracket, that is open this bracket in two places. We have 12 plus X into plus 12 plus X equals to 400 plus 256 give us 656 plus S squared. If we expand this bracket, 12 times 12 will give us 144. 12 times X will give us 12X. S times 12 will give us 12X. S times F will give us S squared. Equals to 656 plus S squared. From there, we can take like times 12x plus 12x will give us a 24x here. So we have 144 plus 24x plus S squared equals to 656 plus S squared. Then we can also take like times. If I take S squared to this side, that may be having S squared minus S squared. That gives us 0. Do you understand that? So S squared will take care of S squared here. So also, that means you'll be having 144 plus 24x equals to 656. From there, you can take like times. You can take 144 to this side. So you have 24x equals to 656 minus 144. That gives us 512. Then from there, our aim is to find x. You can divide both sides by 24. And that'll give us x to be 21.3 centimeter. So that's how we resolve that this triangle, looking for the value of our x, which is side SR. I want to believe you understand this very well. It's a little bit technical than the one you have been solving so far. Now look at this triangle as well. Still on Pythagoras theorem, you have to calculate side AD. Where is AD? Let me find that, which is this side AD. And we are given this diagram. So all you need to do is to figure out all the right angle triangle that are there, and you know where to start from. Now, how many right angle triangle do we have in this triangle as well, or in this diagram? Ask yourself, how many right angle triangle do we have there? But I can see that we have three. How? Triangle AEC is a right angle triangle because of this right angle. Triangle ABE, this triangle as well is also a right angle triangle because this angle on a straight line is 180. If this is 90, that means this is also what? 90. So also we also have that triangle AED. Triangle AE then D. This big triangle is also a right angle triangle. Why? If you remove this side AC, if you remove this line AC, what do you have left? You have this triangle left. So that means this triangle is also a right angle triangle because of this right angle here. So those are the right angle triangle that we have there. And our aim is to find this side AD, which belongs to this triangle AED. It belongs to this triangle AED, which is also a right angle triangle. Then how can we resolve that? If you look at that triangle AED, where this AD belongs to, how many side is given to us? We have this side is not, we don't know this side. We don't know this side as well. And if you look that from here to here, do we know that? Yes, we can find from here to here as well. We can find this side of it. So that means only one side is given to us out of the three sides. So we cannot find this AD yet. So let's leave that one. Let's go to this right angle triangle as well. How many side is given? We have this side AC, and we know this angle, this side EC as well from here to here. How can we know that one? Although it's not given, but you can see it because we can see that from here to here is 6 centimeter. Side BC is 6 centimeter, and we can see that there's a stripe here. There's also a stripe here. It means that BE is equals to EC. From here to here is equals to from here to here. And if from here to here is 6 centimeter, what will be from here to here? That means you need to divide 6 by 2, divided by 2, because from here to here is equal to from here to here. So to get each of these from here to here, that means you need to divide this one by what? 2. So if you divide 6 by 2, that means this from here to here will be 3, and from here to here will also be 3. Don't forget the reason being that we are told that there's a stripe here and there's a stripe here. Though that means that from here to here, which is our EC, is also equal to from here to here, which is our BE, because of this stripe. So that means from here to here is 3. So that means in this right angle triangle that we have here, we now have two sides given. This side is given, which is 5 centimeter, and here we know that this is from here to here is 3 centimeter. So it means that we can find this side now of that triangle. Do we understand that? So you can find this triangle, we can find this side AE using this triangle AEC. Are we there now? Then if you now know this side now, you can now find this side. Since that we know from here to here for this triangle AED, we can know from here to here, because from here to here is given at 8 centimeter, and from here to here is 3 centimeter. So 3 plus 8 will give us the whole side from here to here. And if you can find this, that means you now have two sides of this triangle, big triangle, that you can now find this AD. Do we understand that? So let's find this side now, AE, using this small triangle AEC. So I say from triangle EAC, which is this right angle triangle, our EC from here to here is 6 centimeter divided by 2, knowing that from here to here is 6 centimeter, and from here to here is equals to from here to here because of this stripe. So divide this one by 2, it will be for this one, and it will be for this one as well. So that means from here to here is 3, and from here to here is also 3. So from there from here is 3. If this is 3, then for this rectangle triangle, where is the hypotenuse side, so that we can apply Pythagoras theorem? This is the hypotenuse side because it's facing this right angle. So that means you have AC squared equals to AE squared, which is this side, plus EC squared, which is this side. So AC squared, which is 5 squared, equals to AE squared, which is what we are looking for, plus EC squared, which is 3 squared. So 5 square is 25 equals to AE square plus 9. 3 square is 9. Collect like times AE square will be 25 minus 9 equals to 16. Then to find the AE, take the square root of both sides because of this square here. Then AE will be equal to 4. That means this side AE is 4 centimeter. Now if this side is 4 centimeter, then we can now find our AD. That means from triangle EAD, which is the big triangle, which is also a right angle triangle, we can apply Pythagoras theorem now. Since we know two sides now, we know the whole side from here to here, and we also know this side now, we can find the third side. So the question is, where is the hypotenuse side of this right angle triangle AED? So where's the hypotenuse side? The hypotenuse side is this side AD, because it is facing this right angle. So that means the square of the hypotenuse side, which is AD square, equals to AE square plus ED square. Do you understand that? So we have our AD square equals to our AE square. Our AE is 4. Side AE is 4. So that means the square of it will be 16 plus ED. What's our ED? ED from here to here is from here to here plus from here to here. From here to here is 3, and from here to here is 8. So we have 3 plus 8 all squared. So AD square is going to be 16 plus 3 plus 8 is 11. Then squared of it. 11 square will give us 121. 16 plus 121 will give us 137. Then to find our AD, you have to take the square root of both sides. So AD will be 11.7 centimeter. So you can see how we resolve this triangle using Pythagoras theorem as well. So I must tell you, you have been solving some WAEC past question in this video. Although I didn't tag them WAEC past question, but I just want you to know that some of the questions you have been solving so far, mostly the 3 questions you have been solving before we get to this question, they are WAEC questions. Even this one as well, they are past questions that have been given to students before. So I can believe you have learned one or two things in using Pythagoras theorem. I believe you know Pythagoras theorem now, and you can identify right angle triangles. You can identify the hypotenuse side, and you can identify how many right angle triangle we have in a triangle. If it is more than one, and you can know, I believe you know how to apply Pythagoras theorem right now based on what you have done so far in this video. So to test yourself, to test yourself if truly you have understood Pythagoras theorem, then you may lay your hands on these 3 questions on this diagram, and this diagram. In this diagram, you have to find AB rather, which is this side. You are looking for this side in this diagram. In this diagram, you are looking for AD. Your AD from here to here, you're looking for from AD. So for in this diagram, you're looking for the X, ball of X, which is this side. So try this question, and you can leave the answer in the comment section of this video, and I will confirm whether you are right or wrong if you solve them. So I want to thank you for listening and watching this video from the beginning to the end, and I want to believe you have been mentors very well on Pythagoras theorem. Like I said, this video is to precede our teaching on trigonometric ratio. So in the next video, we're going to be discussing extensively on trigonometric ratio, its usefulness, why we need it, and a lot of things that we can do on trigonometric ratio. It's going to be a wonderful video as well. I want you to stay tuned for the video, and the only way you can be notified when we post the video is by subscribing to this channel, by clicking the subscribe button on this channel right now. If you have not subscribed to the channel, but if you have subscribed to the channel already, please don't click it. It will unsubscribe you. And please comment on the video rather, share the video with the student out there who needs the resource material, and give a thumb up to this video on the channel. And as you do so, may the good Lord bless you. I will see you in the next video. Thank you, and God bless you.